Hi, welcome to Wonder Zone with Cincinnati Museum Center on Facebook Live. We're really excited to have you guys join us this morning. We are going to be learning about non-Newtonian fluids. Today, for our experiment, you're going to need a couple of things. For supplies, you're going to want to have some measuring cups, a couple of clear cups or containers to hold our different formulas as we make them, measuring spoons. Specifically, you're going to need a tablespoon and a teaspoon. Something to stir with. We're using popsicle sticks, a spoon, anything like that will work. A mixing bowl. Then you're also going to want to have a Ziploc bag and just some towels handy. For ingredients, we have a couple of things. You are going to need regular white glue, water, something to dye our slime with, which could either be food coloring, liquid watercolor, water-based paints, really anything that'll stain it. And then the active ingredient is something called borax. Borax is an active ingredient in most common forms of laundry detergent. You can find it in the laundry aisle at any major grocery store, Kroger, Walmart, Target, they all sell it. So, let's talk about slime. Slime is a non-Newtonian fluid, and that is a very cool state of matter. So I want you guys to remember that word. We're going to make our experiment, and then we'll talk about the science behind it. So first off, as any good scientist will tell you, when we do an experiment, we need to make sure that it is replicatable. That means other scientists somewhere else are going to want to try this experiment, and they need to do the exact same steps that we do to see if they get the same result. So to make sure that we're all following the same instructions, I have my recipe, so I'm going to follow it along and tell you guys how to do this. Now, I have prepared a few things already for us. So the first thing that you're going to want to do is take two of your containers, and you're going to fill one of them with water and one of them with glue. I've filled each of these with 1/3 of a cup each so that they're equal amounts. You can use more or less. It depends on how much slime you want to make. So pour some glue in here, some water in here, and then when you've got them all mixed together, you're going to put them in your mixing bowl. And with the glue, you're probably going to have to take and scrape all that out. Get it in there. And then once you've got most of it down in there, you want to mix it all up until you get a good, consistent mixture. Get all that. Try and scrape. Okay. The next thing we're going to do here is we're going to have a cup of warm water. Now, it doesn't have to be hot, and if it's cold, that's okay, but warm water is going to help because what we're doing is we're going to add a teaspoon, 1 teaspoon of our borax into this water, and the warm water is just going to help it dissolve faster. Let's put that in there. And again, I'll mix that up, get it all dissolved. Okay, now, this is my borax solution. This is my glue solution. I'm going to set those there. Before we add these together, I need to decide what color I want. It can be any color you like. I have red and blue and yellow. And if those are the only colors I have, it's okay, because I can still make more. If I mix my red and yellow, I can get orange. If I mix my red and blue, I can get purple. Or if I mix my blue and yellow, I can get green. For today, though, I like blue. It's my favorite color. So we're just going to add a couple of drops. Don't need a whole lot. Mix that up until, again, get everything nice and consistent. Okay, for our last part here, I'm going to add my borax solution into my glue solution. I'm going to do it 1 tablespoon at a time. When the borax and the glue come together, they're going to interact, and it's going to start making the slime, and it's going to happen pretty quick. So as I add it, I need to start stirring pretty hard, and I'm going to have to stir really hard to get it all mixed up. The amount of borax I add depends on how runny or thick I want my mixture to be. So it's really up to you. I'm going to start with just 1, and we'll keep adding more if I need it to be thicker. I already tell this is going to be really runny, so I think I'm going to add 2 this time. So 1, 2. So I've got 3 tablespoons now. And you can see how it's already solidified and made some pretty good looking slime. So check that out. So, whoa, I've got my slime. And this is a non-Newtonian fluid. And that means that it has properties of multiple kinds of matter, and it's very sticky. So, I'll take that off there. Now, matter. Matter is what makes up everything. Literally, it's all of the stuff around us. It's the air we breathe, it's this table, it's what makes me up, it's what makes up your computer that you're watching this on. Everything is made of matter. And matter is made of different atoms and molecules. Yeah. And I have a sticky marker here. Matter can come in lots of different forms. Now, the 3 that we are most familiar with are solids, liquids, and gases. These are the types of matter that we see most often in the universe. They're not the only types. There are things called plasmas, things called Bose-Einstein condensate, and scientists think they're even more than that. But these are the ones that we see the most. The reason these are different has to do with energy. When something is very low energy, really not energetic at all, the atoms are very organized, and they look something like this. They don't move much, and they stay like that. Now, a good example of a solid, we're going to use water. When water is very low energy, like it's really cold, it's ice, and it looks exactly like that. Now, solids have a couple of properties. They hold their shape. I can toss this popsicle stick, drop it on the floor, it still looks like a popsicle stick. I can hit this table, I can push on it, it's not going to give. I can't push through it. It always is like that. I can even, if I wanted, take a popsicle stick and I can break it. But what happens if I add energy to it? So going back to our ice, if I add energy to ice, if I heat it, it becomes a liquid, it becomes water. And that means that our molecules have a little bit more room to kind of spread out, and they're moving around a bit. And you can see that pretty easily here. I've got water. It moves, it doesn't hold its shape. It actually takes the shape of whatever container it's in. So right now, it looks like a measuring cup. If I poured this out and I had enough, I could fill the entire room I'm in, and it would take the shape of the room. I can push through it, and it moves out of my way. So that's a property of liquids. And if I add even more energy, I can turn it into a gas. So if I keep adding heat to water, it's going to turn into steam. And that means that those atoms are all over the place. They have a ton of energy. They're flying around. They want to move. They want to do stuff. They want to get out and go. They have lots and lots of energy. So what is a non-Newtonian fluid now? Well, simply, it is any type of matter that has properties of both a solid and a liquid. So let's look at this. Looks pretty liquidy. It's dripping, it's falling, but as you saw there, I can pull on it and it breaks, it rips apart. I can't do that with water. So this is an awesome example of non-Newtonian fluids because it has those properties of both solids and liquids. Now, slime's not the only type out there. In fact, we kind of challenge you guys, maybe look around, see if you can think of other types of non-Newtonian fluids you find out there. Let us know in the comments. But slime is by far the most fun non-Newtonian fluid to play with. Thank you guys so much for joining us today for Wonder Zone. We hope you enjoyed this. Please, we want to see you guys come back to the Children's Museum. We're really excited to show you everything we have there to play with. We hope you can come and learn with us. And as always, please come back every week to join us for more Wonder Zone experiments and fun. Thank you all so much and have a wonderful day.